probably you see we have that space under that. Get rid of the space there.
So I don't drop it. Okay, it's that cute little program. I got it. Whenever you're beginning to learn a new language, it's always good to give yourself small challenges like this. And it's good to continue to challenge yourself. So if you get it to work right away, give yourself an additional challenge. Can you do it with one right line statement? Can you do it with one variable? Could you do it with multiple variables? How many different ways could you practice outputting this information? You could try a lot of different things just to give yourself some challenges to try some different things to get some more experience. So that's kind of an important thing for us as beginning programmers. Let's see, we had some people that had it done right away. Do we have anyone that wants to share what they did in our Zoom session? Let me stop sharing here. And let's see who we have. Pick on somebody. Okay, go for it. I was going to say I was going to pick on somebody, but that's all right. Because I was going to pick on Aaron later.
Okay, good morning, people. I don't have much of a list today, so.
Good morning.
Here's my code, so I have that right. That's the input. I have where the input, their input. I have my hashtags. This line, I have string formatting, and originally I had a bunch of like plus, single quote, whatever I needed because I tried doing everything in the double quotation. And they said I have too many characters with the string literal type. So I changed how I did that when she said there was escape characters. And then with the formatting, the string formatting, at the end I have character, that's the input that they're writing to. And then it's the same, it's like the same as that one, and then I have that keeps it open. So input a single character was to be sure. And voila. Oh, you're not seeing that?
We're not seeing that. That amazing.
Let's try that again. Share screen. We're gonna take it.
Oh, nice.
Voila.
Ooh, looks good. Give him a hand. Yay. Woo. Early. Okay, I like that. So we're continuing to use the console class there to read data from the console. And Erin, you used the read line command, right? And so we could use the read line command, we could use the read command and the read key command. And each of those have a little bit of differences in the way they work. And so those are the kinds of things, again, you want to experiment with. Because if I stand up here and say, and then the read command does this and the read key command does this, you're going to kind of wander off and it won't really make much difference to you. But if you try it and say, with a read key command, I can only read this amount. With the read line command, I can read everything. So try some different stuff. Let's see who else. Who will you show us? Yeah, because who, if I'm saying it properly, did his just a little bit different and result is the same. And that's what we want to see.
I think this is the main idea the same with the element. But right here, I combine this concatenate recognition with bring my line with one element, so it might be more efficient. And that's it.
Awesome. So whenever we do a \n, we're using that same escape sequence to say the character that follows is now meaningful in this escape sequence, and it goes to a new line. So you can see how Visual Studio highlights that for you pretty dramatically so that you can see it. Can you run it for us? Beautiful. Yay, give him a hand. Surprise program this morning. Okay, anybody else? Look at anything. Show us yours. Bless you.
So this is mine. I did mine a little differently. What I did is I made it where the number of like sharp signals that are hashtags I get printed out of the screen change based off how long the input is, and that's where this new string thing comes in. So you get the input, you'll type what you do, and then it gets how long your input was, and then it'll create a new string with however long your input was, and then +6, and where the 6 comes from is the number of characters that aren't your input. So if you come down here, see there's one input right here, that's space, and that's quotation mark. So and then you should multiply that by 2, and you get 6. So I rerun this. Let's see. Type something. And it'll format it like that.
Nice.
And if you were to type something like a lot longer, like a bunch of random characters, it'll format it so that it looks nice.
Very fancy.
Yeah, that's it.
Looks good. Give him a hand. Yay. Thank you, Jacob. And what we wanted to look at next in chapter 3 was creating new instances like that, like Jacob did of the string class. So I'm going to take over here, steal it. And I'm trying to figure out how to get this information to you better than I have. In chapter 3, there is some content at the end of the chapter, the iteration constructs, which talk about looping, and decision constructs, talk about if statements, that we will really be covering a little bit later in the semester. So if you've read through that content and you're comfortable with it, that's great. I'm not going to say you can't use it, but it's not content that we will be working with until later. In chapter 4, which we're really kind of starting on this week, again, the arrays, content, and understanding C# nullable types is stuff that we will be covering later in the semester. So our book is a little bit disjointed compared to how we want to cover things. So again, I'll get this published to you so that you know which sections you can kind of skip. Again, reading through them is not going to hurt anything, but I don't want you to feel overloaded or overwhelmed with it because we won't be working on it quite yet. So we left off last time looking in chapter 3, and we saw this huge table of all these different data types that we can use in C#. And we were talking about how C# is just very, very much type specific, strongly typed. It's a strongly typed programming language. And that means it really likes to know the data type of everything that's going to be being used. We wrote a quick program where we displayed a lot of information using some different formatting characteristics that we could use for numeric data types. Let's try a few more. I want to open another Visual Studio project. So I'm going to create a new project. I'm going to change my location. It seems like the stuff that I want to save on my OneDrive doesn't go there, and the stuff that I do won't. That's all right. And I want to name this Chapter 3. And they've got some stuff about variable declaration and initialization. Let's just call this new variables. And as we get in and looking at the code, I think that you'll know what I mean there. Whenever we're working with C#, I've shown you a couple different comment types that we could do. A // we can do a // at the beginning of a line to make that whole line a comment, or we can do a // further on in a line, in a code line, and then the rest of the line becomes comment and is ignored by the compiler or the interpreter. We also can use a /* as the beginning of a block comment, and then we can use an */ to end that block comment. But there's another type of comment that we can use in C# that's really, really valuable, and it's called the XML comment. And it actually can be more useful after we've written our code, but I'm going to put my insertion point here above my class statement, and I'm going to press enter to open a new line. You don't have to do it exactly this way, but it's the best. And then I'm going to type 3 // And notice as soon as you type the 3 // that Visual Basic or Visual Studio, does some rearranging for you. And what it does is it creates this begin summary tag and this end summary tag. So it's basically creating a summary comment for your whole program. And this XML comment will be available to other people if we were to share this code. So let's put a summary in here. We will be exploring variable declaration and initialization. Now I'm going to go down into my main method and make sure that I'm within my curly braces for my main method before I start typing this code that I want to put in. I've got the console.writeLine command. You know I don't want to type console over and over. So that reminds me, I better go back up and fix my using statements. I want using system, and then I want using static system.console. And then I can get rid of that console keyword and just use my WriteLines command. And the first WriteLine is going to be like a header. They've got an equal, greater than as kind of an emphasis. And then data declarations. Sometimes when we're writing code for assignments, we can get pretty rushed and leave out the nice things. We don't want to do that. So it's always nice to have a nice heading to let people know what's going on. First, we're going to declare some local variables. And we talked about how to declare these last time, but just really quickly. First, I'm going to declare an integer named myInt. This declares an integer variable. Now notice it has that squiggly green line under it. If you mouse over that, you'll see the interpreter is complaining to you that you've got this variable, but it hasn't ever been used. So that's what that green squiggly line is. It's not even a warning. It's just letting you know that you don't use that variable. You might want to get rid of it. Next, we'll declare a string variable named myString. And then we'll do a blank WriteLine. Now we should be able to run that even though we've got these green warnings. So I'm going to press Control F5 so that my console will stay open when I run this. And I shouldn't really have anything other than that data declarations heading is output. Look good, everybody's run okay? No errors, because we just want to make sure we don't have any syntax errors at this point. Now let's try to use our variables. With our string variable, let's assign it a value. My string equal, this is my character data. So a few things. We can declare the variable on one line and initialize it on another. Whenever we set our variable equal to something, that is an assignment statement. And you may have learned about that in a different programming language, but anytime we have just one equal sign, we're assigning a value to a variable, so that's an assignment statement. Now I want to press Control F5 again to run that. I'm still not seeing anything output, right? But at least I know that I'm not generating any errors. So we could be outputting some of this if we wanted to. If you feel like you want to, you just go right ahead. The next thing that they'd like to do, though, in their effort here to declare a bunch of variables, is let's declare 3 bools on a single line. So 3 Boolean variables. We could do this with any data type. We're going to say that our Boolean B1 is equal to true, our Boolean B2 is equal to false, and our Boolean B3 is equal to our Boolean B1. And all of those would be completely legal. Whenever we are looking at that bool keyword, that's really a shorthand notation for the system.boolean object. So we could actually allocate that data type using the full name. So we could see some things done in a little bit different way. Let's try it. System.boolean B4 equals false. You know, those programmers, sometimes people like to do things just a little bit different than everybody else just to be a pain, and we can always figure it out. All right, we've got all these variables. Let's output something. I'm going to create a right line statement here. Your data. And then we're going to use some output parameters. We know that if we use a number within curly braces, within our double quote string, that becomes an output parameter. And it's really just a placeholder in that output string. So we did a whole bunch last time where we used parameter number 0, but we'd like to try more than that. So we're going to have parameter number 1, parameter number 2, and I'm putting a comma between each of these because we want the comma to be output in our output message, not because I need it for the code. And we're going to have 5 parameters for this one. Now, I'm going to list all of those parameters after the closing double quote. So the parameters that we want to replace all of those different values with are my int variable, are my string variable, B1, B2, B3, and B4. Mine is upset with me. It says that you have this variable, my int, but you've never assigned a value to it. So we can't output it. So when I declare my integer, my int, I can go ahead and assign an initial value to it of 0 so that I don't get that error. And now I should be able to run this and output all of my data. So my int is 0, my string says this is my character data. Then I have true, false, true, and false. Is everybody's printout okay? All sorts of good stuff. When I'm working with Visual Studio, over here in my solution, I have this project that's chapter 3 new variables. Well, I could create another project if I wanted to and do something a little bit different for some additional testing. So to do that, go up to your solution, and on your solution, I'm going to right click and choose new project. Oops, sorry, add new project. Left out the add. And this next step is newing data types. I'm just going to put it like they have it. Doing data types. Now, if you look at your Solution Explorer, you should see the project we were working on and our new one. The one we were working on has a bold header, and that means that it's the default project if I click Run. I would like to make this new project the default project if I click Run. I could keep several projects here in one solution, so I could look at all of these examples without having to open a bunch of new ones. It's kind of handy. So to switch which one is going to run when I click Start, I'm just going to right-click on the one I want to make the active one and choose Set a Startup Project. I lost it. I couldn't find it. There it is. Now, if you click on the other one, you should see that this one is bold now. Now, notice they both have a program.cs file. So you have to be careful of which one you're looking at. In our next one that we create, we'll rename that program.cs file so that we can be sure which one we're looking at a little bit easier. Which one? Yeah, sure. So on your solution, right click and choose Add New Project. And then when you add a new project, give it Newing Data Types. Yeah, make sure you're on your solution. So it's one of those things where you have to be in the right place. Now I'd like to put some comments, and again, I like those XML comments, so I'm going to do 3 slashes, and this class will show new data types. So in this example, we're going to be using the new keyword to create variables. I'm going to update my using clauses, using static system.console. Got it? Okay, so we're going to be using new to create variables. So I want to put that in a right line statement. And if you notice the right statement that drops down when we're looking at the right line, the right statement will write output but stay on the same line. So if we want to add additional output, we can use that right statement. So our output is going to say using new to create variables. When we're working with C#, we said everything is object-oriented and everything inherits from the default system object. And this really does make our lives easier, and it makes it easier to work with things in the long run. Every data type that we look at has an equivalent object. So with our bool, let's declare a Boolean variable named b. We can say that it is a new Boolean, and that's going to set it to false. That's the default for a new Boolean object. Now with an integer, if I declare an integer as a new int data type, that's going to set that integer's initial value to 0. So that's the same as that last example where I said int a equals 0. It's the same effect, the same net effect to us. Now if I want to create a double object as a new double, that's going to be set to 0. And then one that we hadn't seen before is the date time type object. So we can declare a date time object named DT and say that it's a new date time. Now that's going to be set to 1101 at 12 a.m. Now I'm going to do a write line to output all of those data elements, just like we did before. So as parameters, we're going to output parameter 0, parameter 1, parameter 2, parameter 3. And after parameter 3, we're going to close our string. And after we close our string, we're ready for a comma to start our list of variables that we want to use for replacement. So we have B, I, D, and DT. Not very good variable names, but for our short program, they'll be okay. And then I'm going to do a blank write line. And let's try running it, making sure that it works. And we should see our variables that were created with a new keyword. We don't see a lot of difference with them. We're just using them as an object. Let's try a couple of these neat things. I'm going to add a little bit more to our output here. This next example that they have, we're going to output some information about data type functionality. Now, when I'm using an integer, I have some properties that are available to me, properties of integers. And one of those things that's available is the maximum value that I can have as an integer. You saw with Jacob's example, he used a property of the string family to find out how long that string was, the dot length property. Here we can use the max value of an integer to find out what the maximum value of an integer is. Let's go ahead and output also the minimum value. And then we can do the same thing with doubles. Gotta put it in there. So my max of a double not close my string. There we go. And then I want that minimum value for the double also. Let's try it. example, so if we use that new keyword and we create our variables as objects, we have access to the functions and methods that are available to objects of that type, like this min and max value. So information that's available in the rest of the chapter is really, really good stuff, and it's going to be useful to you throughout the semester. So always remember to refer back to this chapter to look at things. Okay, has everybody got that? Got it all set? I'm going to do a save all. And then I'm going to close that. If I can, I'll try to zip it and post it to our Discord channel. See if it will let me. Is it there, or is it just pretending? I get hung a lot and have to kill a Discord and restart it to get it to work. Okay, just so you can have some code just in case. So we're going to talk about methods next, and it's in chapter 4 of your textbook, and it starts on page 118. So there's a little bit of chapter 4 you're going to skip because we're not going to talk about arrays yet. Yeah, you can look at it if you want, but I don't want you to get off stressed that there's too much info all at once, because our book does present a lot very quickly. Now, when we're talking about methods, we're talking about subprograms. And I want to go through this presentation a little bit before we break for our lab today, so that next time we'll be ready to just start off with some practice and getting our REPL done and all that good stuff. So anytime we talk about a subprogram in C#, I've said it already, it's called a method. Took me a while to get used to it because I was used to calling things functions, subroutines, all those kinds of things, all those different words. And I remember having students practically in tears saying, when should I use a function? When should I use a subroutine? Well, now that there's just methods, it doesn't matter. You just use a method. So it makes your life a lot easier. They're all the same. So a method is just a chunk of code, and it's a logical chunk of code that's defined and it can be executed. So we use methods to separate functional tasks in our program and to eliminate redundant code. If we see something that we're doing repeatedly, we probably want to make that a method and call it instead of having that code be repeated over and over. Methods help us maintain a maintainable, object-oriented, modular programming style. So gives us all of the ability to have multiple people working on a project because we have everything separated out into its own functional logical component. So here's a hierarchy chart. If you remember these from your 120 class, they're the really, really super easy ones. And all a hierarchy chart has in it is what subprograms are called by what other subprogram. So looking at this hierarchy chart, it could be a C# program. I have a main method, and my main method calls an input method, and a process method, and an output method. So it's very organized. And it's going to eliminate duplicate code because, like Bart knows it, less code matters because that's less that you have to write. A couple of things about methods. A method is like the chorus to a song. It's something that might be repeated over and over. It could be like a recipe you use over and over. Be something that's done the same way each time. It could be like doing the laundry or cooking dinner or something that might result in something to eat or something maybe that won't result in something to eat. But that's what a method is, taking that piece of repeatable information and separating it out and defining it so that it can be reused over and over and over. So a C# method has three primary components: the method header, the method body, and the method closing. Those are our important parts. Whenever we're looking at a C# method, the header can be kind of ugly when we're first getting used to it. And it can have a lot of pieces that are optional. So this method header shows all of the things that a method header could have. It has the keyword public, and we can leave that access level off. We'll default to private, but in a lot of our code, we'll just leave that off for now as we get started. But we could put that on if we wanted to. Next, we have this optional keyword static. And a lot of the methods that we've used so far have had that keyword, and we'll talk a lot about what it means. Next, we have the type of data that's going to be returned or output by this method. This method says void. That means it's not going to return any data. Next comes the method name. This method is named my method. Then within parentheses are all of the parameters that are required as input for this method. So static is a modifier. Void is the return type. My method is the method name. And then within the parentheses is the parameter list. Now this method header only has one parameter in the parameter list, but I could have multiples if I had commas in between them. The method header ends with an opening curly brace. And that signifies the beginning of my method body. So if I have a C# method, the code inside the method is my method body. My parameter list is going to end with the closing parenthesis, and then my method body is going to begin with this opening curly brace. My method body is going to end with a closing curly brace. So just like all of the other things in C#, likes to be delimited, beginning and ending with a closing curly brace. And the code inside there is the method body, and I can use any sort of C# code that I like. Here's an example. In this example, I have my main method, and then I have a method called my method. The main method calls the method my method, and it passes in a value of 7.5. That argument is used to load up this parameter variable, my variable. So when I run this program, the main is going to start. It's going to call my method, passing a value of 7.5. My method is going to start running, loading 7.5 into that variable. It's going to execute this one line of code to write this output to the screen. So our output is going to be My variable is 7.5. Now, when this method hits this closing curly brace, the end of its body, execution is going to return to our main. In this main, we don't have any more code, but if we did, we would continue executing code here in our main method, where that method ended. Okay, so what if I want to return a value from my method? I want some output. Well, then I just specify a data type instead of that keyword void. So right now it might not look like it's in a certain place, but it really is. So I've got my static modifier, and then right after that, that return type. So in this example, it's changed from void to int. We're saying this method is going to return an integer data type. The parameter list and everything else is still the same. So when I say that I'm going to return a value, I have to have the return keyword somewhere in my method. When execution hits that return keyword, execution is going to immediately return back to the calling method with that value being supplied as output from our method. Just like I create a function with a calculator. So when we return a value, we're going to use the return keyword. We're going to specify what data to return. And our data that we return could be anything. It could be a literal, like the number 5. You could just say return space 5. It could be a variable name, and we'll be returning the data that's in that variable. But for C#, when we're returning a value, we can only return one thing. So we might pack a bunch of stuff up into an array, or maybe try some other way to put some things together, but we can only return one thing. One int, one string, whatever it is we're returning. So here's our code changed a little bit. And in this example, got a little bit more code. Here in our main, we declare an integer named return value. Then we call our method myMethod, again passing the value 7.5, but this time we expect output from our myMethod. We can tell we expect output because we have a variable before the equal sign. So we're saying whatever output I receive from my method, place that into that return value variable. Then when we do a write line, we'll have the return value. Let's take a look at that a little bit more, how it's going to start. We're going to start by executing our main. The integer return value is going to be allocated. My method is going to be called passing a value of 7.5. My method will start running, loading up the value 7.5 into my variable. The write line statement will be executed, and we'll see the output. The variable is 7.5. Then the return statement will be executed, and in the return statement, we multiply my variable times 2. One thing to notice in the return statement is because my variable is a double, we go ahead and for safety's sake, cast the answer is an integer. And that's what placing that data type within the parentheses is a casting, where we're saying we want to turn this into an integer. Now, if that can't happen properly, C# will cancel at that point, but if it can, it'll convert it to an integer. The data then will be returned to the main and placed into the return value variable. The write line will be executed, and it will output the return value is 15 or 14. Have to try it. Now, one thing I wanted you to notice is this line of code down here is the same result. Instead of declaring an integer and calling my method and saving the result, I could do all of this in this one line of code by just calling our my method right within our right line statement. Now our parameter list can have multiple data items, but every data item, every variable has to have its data type and the name the variable is going to be given. These parameters are in order and separated by commas. Now, when I'm in my method, this parameter definition right here is exactly the same as me saying double my variable, semicolon, within my code, right? It allocates that my variable as a double. It's just that it loads a value into it from the call. This is exactly the same as a separate line of code that says int my int. It declares my int as an integer. So those variables are now available to that method, my method. They're local to my method. They're not available to the main or to any other method, just to this one. So our method signature is all of these things. They can, like I said, be a little bit confusing at the beginning. But as you get more experience with C# and with method signatures, you'll understand why they are the way they are. The method signature is comprised of all the different pieces: the return type, the method name, the parameter list, everything. In my example so far, I've had 3 different method signatures for the my method. Could I do that in one program? Yes. I could have my method coded those 3 different ways. Then depending on how my method was called, C# would call the right version of my method. So if I were to call my method passing a double and an int, C# would say, oh, you want this version. So the signature helps us figure out which method to call. That's an overloaded method, where I can have the same method with multiple signatures, and I can have it do different things. So maybe in my method that accepts a parameter of a string, I'm going to search for an employee by name. That maybe in my method that accepts a double, I'm going to search for an employee by employee ID or some other sort of numeric value. So I can offer up these different methods, these services to others, and I can have the same method name do multiple things so that I can make things more flexible. That's overloaded methods. And we're going to talk about these a lot as the semester goes on. We're just getting started with looking at methods. C# implements functions and subroutines as methods. So every time I say that, that's what it is a subprogram. Each method has that unique signature that's developed from its header. So its header is pretty important. That header specifies input that's required by the method, the data type of that input, the sequence of that input, and a method header specifies the data type of the return value supplied by the method. It has a body of code, and the code body is enclosed by braces. Now, in our book, we have some examples that we're going to be working on next time. You can be looking through some things and reading stuff. We'll try some examples. We'll have some time to work on that REPL. You have plenty of time. You don't need to get started on it yet. Right now is a good time to be reading and trying some experimenting, just working with things. The other assignment that was out there for week 2 find it here, was the this 2 numbers project. So if you feel like you need a challenge, do work on that one. Otherwise, we want to be reading our chapter and getting prepared for working with methods more next time. There are a bunch of videos. The carpet calculator walkthrough deals more with that Doyle book, but it's a really good example of working with some methods too, if you want to go through that, if you want more practice. Any questions? No good? All right, let's try something different then for our time. Let me give you this link. I'm going to post it to Discord. This is a Quizlet link. If it will, oh, I don't know if it's going to go. Nope. I'll put it in our chat, and then I'll kill my Discord and restart it. Okay, now it's on Discord. Okay, so that Quizlet deck, if you can find it, has a lot of terms. Kind of scan through those. And at 9:20, we'll do a Quizlet live until 9:30, and then we'll get out of here. So I'm going to set my alarm for 9:20. So scan through them so you can be dangerous.
The Zoom chat here, this is where the message next one is. I don't think any of you guys have access to it. Oh, really? I can't access either. Let's try it again.
Yeah, it says you're not allowed to view it.
Oh, that's my bad.
Is that all of you?
Is it working now?
Is it working?
I hope so. Yep. Okay, sorry about
Yeah.
that. I was like, why is anyone else on here?
You were just doing all the work.
Oh, I have a lot of stuff now. It's a good ass. You know what? You don't know the secret handshake.
Just refreshes the secret page.
Yeah.
We can't play them. Oh, yeah. I don't play them. Some people just get so powerful, which is too. Stuff if you want to. There's so many different terms.
Like it was.
Getting a handle on the term is definitely helpful.
We got $2,000. Pretty good chance.
That's what it is to me.
Yeah. Am I? I won't trust you. Had a set of invitations here. How to step, start accepting votes.
He told me to read this week and please select this assignment. I can't believe this one. I feel like, is there any way for this one to actually? Refresh.
Just do it again.
And also, I have
Doing whatever you feel.
one more question. Also, I think about stuff about lesson 3 on that one. Do you just go back and look at, or do I just know? Sweet.